All right, class. So, welcome to part 2 of the 5.1F lesson. We just have one more page to go, and this last page involves taking something in scientific notation and adding it with something else in scientific notation. Okay. We're going to go over what you need to do in order to add two very large numbers together that are in scientific notation. And you may run into a little bit of a hiccup every now and then, but let's just talk about the property of it all, right? So it says, can the distributive property be used to simplify 6 times 10 to the ninth plus 2 times 10 to the ninth? Explain why or why not, and then simplify if possible. Okay, so the first thing I want us to be reminded of, I'm actually going to give you an example before we even try something like this, right? So let's say I had 5 times 2 plus 7 times 2, right? And you can see that this is kind of like distributing. I'm multiplying the 2 to both the 5 and the 7, right? So if I were to pull the 2 out from both terms, I would get something like this, right? 2 times the group of 5 plus 7, which essentially gives me 2 times 5 and 2 times 7, right? Now, this would give me 10 plus 14. This gives me 2 times 12, which is also the same exact sum, right? So essentially, we can rewrite this in terms of something that's like distribution if and only if these two numbers are multiplying or being multiplied by the same magnitude, right? The magnitude in this case was the 2, right? So going back to number 12, it says, can the distributive property be used to simplify 6 times 10 to the ninth plus 2 times 10 to the ninth, right? Notice that they both are being multiplied by a 10 to the ninth. So the answer is yes. These numbers are being multiplied by the same magnitude, right? This can only happen if both of these groups are being multiplied by both of these numbers really being multiplied by the same magnitude, right? And if that's the case, then we know that all I have to do is add 6 plus 2 and put that in a group. And then the 10 to the ninth can be kind of like what's outside being distributed to each of these, right? Now, I hope you're realizing why we did that. Like, we did this because then that means we can take this addition, right? Multiplying two large numbers that are in scientific notation, making sure that they have the same magnitude. And then once they have the same magnitude, we just have to add 6 plus 2, and we get 8 times 10 to the ninth. And that's our final answer. Right, so this is a little bit of like some wizardry and some math calculations. Like once we have two things, remember we're adding here, right? We're not multiplying, because if we were multiplying, then we would just be doing more of the same thing that we saw in this lesson, right? 10 to the ninth times 10 to the ninth, that's easy. But if we're adding two numbers, right? Like Mr. Quo's bank account with Bill Gates' bank account, right? If we're adding both of our bank accounts, then you first have to have the same magnitude before you can shorten, the process. So let's try this. 13 is saying 4 times 10 to the 7th plus 8 times 10 to the 7th. Again, they have the same magnitude, so we're okay. We can immediately just add the 4 and the 8, and we get 12 times 10 to the 7th will be our final answer if this was in scientific notation. So that was kind of a trick question. This is not in scientific notation, So you're going to have to move one placeholder again, fix it up. Just kind of like you got to edit it a little bit. Take away a placeholder, add a placeholder. Your final answer is 1.2 times 10 to the 8th. Okay. You can also do this with subtraction. Notice how they have the same magnitude again. So all we have to do is just subtract these two numbers. 54 minus 19 is going to be 35 times 10 to the 6th. And then we have to fix this. Take away a placeholder, add a placeholder, and your final answer is 3.5 times 10 to the 6. Oh, I'm sorry. 10 to the 7. I'm sorry. Okay, so remember, this only worked because we were multiplying by the same kind of factor, right? You can take the 10 to the 9th and just say, hey, I could just take it out and then just add these two, and that would give me the answer, right? But can the distributive property and exponent rules be used to simplify the expression 5 times 10 to the 9th plus 3 times 10 to the 4th? Explain why or why not. So this is a huge point, right? Can we really use that shortcut that we just showed you with 5 times 10 to the 9th plus 3 times 10 to the 4th? Some may say, yes, you can, Mr. Quo. All you have to do is make sure that the magnitudes are the same, right? Whereas some would say, the magnitudes are not the same, so you can't do that, right? I would agree. Currently, you cannot do that. But who's to say, can't we just edit 10 to the 9th and make it 10 to the 4th, right? It is possible. Now, it's probably not the best example right now, but you would. I think the idea is we can use the shortcut seen above if and only if the magnitudes are the same. Therefore, edit the 10 to the 9th to make it 10 the same as the other group. Factor before starting, right? Before. So we have to make sure that the 10 to the 9th matches the 10 to the 4th. And you'll see how we do that very soon. So the rules to add and subtract numbers in scientific notation state that a times 10 to the n plus b times 10 to the n is literally a plus b times 10 to the n, as you saw in the example above. And then a times 10 to the n minus b times 10 to the n is a minus b times 10 to the n. Okay, so this is a lot of theory, a lot of fundamental stuff. Let's just practice. Okay, so I think this will make much more sense when we practice. Okay, so take a look at 17. Again, if they both had the same magnitude, we would be able to just immediately say, oh, 4.12 plus 3.94, add them, and then multiply by 10 to the 6. However, they don't have the same magnitude this time. This is a tricky question. The key question is, how do I make 10 to the 6 turn to 10 to the 4th? Think about that, class. How do I make the 10 to the 6 turn to a lower exponent amount of 10 to the 4th? It's kind of like, well, why don't I just use two placeholders, right? So I'll call it use two placeholders. And if I use two placeholders, that would essentially force myself to utilize the two placeholders here with the actual number. I use two placeholders plus 2. That allows me to subtract 2 from the 10 to the 6. Right? Then my new expression is going to be 412, because I used two placeholders, times 10 to the 4th, plus 3.94 times 10 to the 4th. And what we've done successfully with this example class is we now have the matching magnitudes that we need. When we have the matching magnitudes, boom, now we can add these two numbers again. 412 plus 3.94 is 415.94 times 10 to the 4th. Now, unfortunately, this answer is not in scientific notation. So we're going to have to do a little bit of editing again. And we're going to take away two placeholders and then add two more placeholders there. Wow, your mind might be all over the place. You're like, Mr. Quo, what are you doing? What's going on? Right? This is, I have to admit, class is not the easiest, but once you get the hang of it, you'll realize, oh, I get it. You have to match the magnitudes. Once you match the magnitudes, you can then add these two numbers together and just multiply by that same magnitude. Essentially, it's kind of like distribution, right? Distributive property. Once I have the same magnitude for both, then I can just add these two and then multiply by that magnitude. So your final answer is 4.1594 times 10 to the 6th. This is in the rare case where you want to add a very, very large number with another very, very large number, and you're just trying to see, is there a shortcut to that? And that's what scientists do, right, class? So there's a lot of validity to this process, so please give it your attention. Okay, I'm going to leave number 18 for you to try on your own. Cool. Thanks for watching, everyone.